And then coming back to what were these potential contributions, no? They are related to the exploitable results, okay? But they are not exploitable results. For example, regarding the ontology, so you cannot read, so I will put it. Regarding the ontologies and data models, for example, one thing where we could not contribute with a new standard, but giving feedback to our existing standard was a new feature for the SRF family of ontologies. Okay? This was one use case that it was not taken into account in SRF, but we had in the project. So we said, okay, so this is something that can influence this standard. So it's, for example, in this case, the goal was to contribute to a new feature in a standard. Okay? For example, another thing that we have been developing is the visual notation for creating diagrams for ontologies. So here, it is not something that we are going to make a standard, no? Because this is one of the things that would take much more time, no? We can talk about this now. After the end of the project, but this is something that we can start applying, for example, with the SRF. Regarding the digital twin platform, no? For example, we have the use cases of digital twins in the construction domain. Okay? Here we can contribute to ongoing standards. We already in ISO and subcommittee 41 on IoT and digital twins, they were collecting use cases and making a technical report with use cases for digital twins. There, we contributed to one use case in working group 9 in the CEN committee. We have now submitted. So these are places where we can support in some way standardization. Another thing is the architecture for digital twin applications. So right now in ISO, again, so it is starting the process of defining the technical report on the architecture for digital twins.
Who are you talking with?
So there, the work just started, and the plenary meeting that is this week is like the launch of the table of contents and things like that. So this is something that.
But it's led by you, or it's
no.
No, because I'm establishing liaison with this working group.
Okay, so I can give you the name of the editors. So here, so from our side, I'm not interested in also because in ISO, for example, so right now it was voted for publication the technical report with the vocabulary, and it has been like 3 years for making that. The use cases is something similar. This is like in the long term.
I know.
But this is something where we can give some feedback, no? And so, for example, which is the role of ontologies in digital twins? So this is something that, for example, in ETSI, in the Smart End-to-End Committee, so there is some work being done related to that, no? On what is the role of semantics in a digital twin, how can we support that, and so on. So here I will develop a new standard. It will be like giving feedback to the community. And then I mentioned before the thing that we are doing on creating the knowledge graph, but at the same time keeping the raw data, the point clouds, the IFC model. No, we are not converting everything to the knowledge graph. No, so this duality that usually is not reflected in current standards. No, for example, we are following the Web of Things approach. Okay. And there, this duality doesn't exist. This is something where we could, again, we are not going to say, okay, we need a new standard, but for example, for the standard of thing descriptions or discovery, we could give feedback in order to make a potential future standard. Okay? Here, this is more something that we don't have clear. We think that it is useful, but we don't know yet how or where. No, how we can, once we have the IFC model and we want to ingest it into the digital twin platform, all the things that we have to do, okay? Because at the end we have to transform it, we have to store it, we have to keep the links between the things and what we are going to link. The graph with the IFC file or the column in the graph with the column in the IFC file, no? How to manage these correspondences, no? This is something that that we think that is interesting. We don't see no one working about this, but we also don't see where we can talk about this. No, so
actually, I think it's the most important point.
yes, but right now there is no move. I don't know.
That would be like a guide for the digital twin management.
That's it. So, but right now I don't know where to discuss this. No? And then another thing is from all this construction of, this is more from the linked data perspective. Once we are constructing our knowledge graph on different sources, that heterogeneous, decentralized, how to formally, let's say this is for the governance part, how to formally specify the process, the pipeline, we call it here, no? The pipeline to follow to create this data, so it is ingested correctly, validated, no? And then you have the knowledge graph. And again, here, for example, in W3C, we have the knowledge graph construction community group that is more from the point of view of knowledge graphs. We have the link building data community group more from the point of view of buildings. So this is something that our idea again is to present it to these groups, you know, what we have done. So as you can see, our ideas are not to create a new standard or to say, okay, our platform should be a standard, no. But we think that we can give feedback to different places, no, and work with that. Also, for example, one of the things that could be interesting in the scope of European projects are the CEN workshop agreements. This is something that if we notice some commonalities, we can work with that goal. CEN workshop agreements are like, we have also that at ISO. This is like a fast track standardization. You put some institutions together, you propose a workshop where you are going to discuss some topics, and then you come up with a document, like a technical report, with a temporal validity, but is published by CEN. Okay? So this is something that we analyze, but again, here we have the problems of the timeline of the project. This is something that takes from 6 to 12 months. You have to organize these workshops, collect the people. I think that you needed some funding also. So this is something that requires a lot of work and involvement beyond your project. So this is...
Actually, that was the reason to create the video. I've been involved in so many European projects. At the end, you are doing really nice things. The project ends and everything stops. So, and I remember somebody told me, no, but at the end of the project, you can create an association and try to put things forward. I said, do I have to wait for the end of the project? Let's do it right now. I guess that's what we did.
And it's useful for the sustainability of some of these things. No? And that's it. So from a COGITO perspective, this is a bit the things that I brought to discuss. No?
Many things open, but it's really good. Yeah. That's really good.
Thank you all. Very interesting. Well, talking about standardization and BIM2TWIN, well, this is something I would say that has just started on our side, and well, we have this standardization issue also in mind. Exactly what you said. I mean, after the end of the project, we don't want to die, and we don't want to put everything to the trash. Well, as I presented very rapidly just the session before, the first statement that we can say from BIM2TWIN side, we were quite satisfied with the existing standards. So we have a methodology to gather, to understand our needs, and then to do our shopping through existing standards. And at the end, of course, even if 80–90% of our concepts were coming from existing ones, were defined, standardized externally to our project, when we extend some of them for our specific needs. I cannot say it was impossible to reuse 100% of existing, but for a reason of time and well, we developed some extensions for us. And when now, so this is the first aspect. I shortlist on the right side our sources of information, mainly about IFCO and so on. So there are it's just a short list, but we have been shopping through a longer list of ontologies. And now we are trying to think about, well, about standardization action. Of course, the first one will be to publish what we have done. Maybe we will adopt something similar to the portal of ontologies you have done. I think it's a very good idea that you that you gave us. It will be one way. But again, what about the afterlife of the project for that? And the idea also, and this is the purpose of such workshop today, it's the identification of relevant initiatives that are lasting longer and where we can, put our development conclusions in their hands in order to go further with that. So on our side, we have already identified the Building Smart International in order to publish there our use cases. So it's something that is derived from the IDM approach, where you can document your workflow and the exchange requirements among the different tasks and subtasks in your workflow in a very formal way. So maybe this is also something that we can do and we can use. We have with us in the consortium, we have Technical University of München. So André Bormann, who is somebody very close to this Building Smart Association. That's why we have this link. But we are also discussing with you, Edouard.
Actually, André has been appointed. And public information.
Yes.
Inside the technical, into the working group 2, I think, which is exchange requirements. He is leading a technical group inside. Okay, I don't remember exactly, but I saw this morning. Okay?
Yeah, and you mentioned the fact that you have already received some use cases from BIM2TWIN, so I think it's through André. Yeah. Okay. And having said that, and also with what we discussed this morning, how to still I have some open questions. How to make that alive, and how to take into account the changes, how to take into account existing vocabularies. And how to manage the life cycle of these standards as they will evolve over the time, and will be the BDTA, for instance, the key instance to give the key on the management of that. As you know, on the construction sector, we have a database maintained more or less by Building Smart. Should we duplicate something similar?
Right now I'm talking about GDTA. Okay, so the first call when we had constituted the association was talking with BIM2TWIN. Okay, just trying to find a way to collaborate. Okay, and obviously our ambition is to be complementary, not trying to do what they have been doing so far really successfully. Okay, so from a point of view, okay, for example, in terms of definitions, I think this is not even the BDTA who has to say this. From a point of view, it has to be the working group 9, okay, which is trying to harmonize these definitions with manufacturing, but also with people from the working group 1 talking about terminology. Okay, so and in a standardization, they are really picky with the the names. Okay. Okay. When we started with the use cases, okay, Dan with the convener of working group 1 said, but you want to collect use cases or case studies? And I say, what? Because it's completely different now. Okay, just please give me this information. Okay, because at the end, okay, from one use case you can have different case studies. Okay, and actually by having different case studies you can infer the use case, and actually it's part of the new document that we are providing, that we are working on. Okay, trying to have case studies that will provide us with clear use cases. Okay, as potential benefits. But you know, this is just an example, okay, of how it works. This is why it's so slow. You were mentioning, Raul, that it takes time. Yeah, actually, when in the kickoff meeting, I was like, oh, but I want to do this, and people were like, hey, be quiet, because that's a long, short planning. Okay, so, and it's true. Okay, but it's a long running because that. Okay, because we have to harmonize, and what is great that BDTA is a portal. Okay, for getting into, okay, or to have, let's say, a more easy discussions, okay, and that we can afterwards upload, okay, to the or to propose. Okay, I think that could be a really good way to do, okay, and for example, we were discussing just before entering, I think it would be doing a workshop like what we are doing right now. I think it would be really interesting, even online, trying to have one in, let's say, in September online, okay, with all the sister projects, trying to get, okay, on the slides like that you have shown, okay, trying to see what could be at the end we cannot do everything, okay, so let's try to pick one or two, okay, of the things that we can do in a common action, let's say. I was proposing to meet, I have to talk with Nadia, but I'm sure that they will be pleased to have this jointly with the simulation workshop, okay, in October. Okay, so we can meet there. Okay, and afterwards in Barcelona in April, okay, we have like a final workshop in there, okay, trying to extract direct conclusions that we can upload in working group 9, or maybe in the SC41, okay, the working group 6 is the digital things, okay, for manufacturing, but it's like more generic, okay, so, and I'm in liaison, or I'm establishing a formal liaison with them, okay, trying to get this harmonization. So, from a point of view, if just a sphere proposing our white paper of 2019 is completely different than if we are including in them, okay, all your thoughts, or your, let's say, place of compromise, okay, of finding terms, finding the methodology, okay, the methodology is key, okay, at the end the processes, okay, and if we can include this process, for example, with the IDM of building smart, which is well recognized, and there is an ISO which underpins. That's perfect. Okay, and there's something that could be considered an extremely good result from each project.
Yeah. Yes, I don't. Well, our model is published through GitHub, but I don't know if it's public. And I think it's not public for the moment. It's just among us in the consortium, and I don't know how it will cost to align what we have done with your, with the way you publish it, in order for us to ease the superimposition of these two approaches and see what are the commonalities, what is different. We can say we have made the same use of the same ontology. Even that is not sure. It's interesting because, for instance, you were mentioning SAREF, and unfortunately, I will have to confess that we don't have IoT system in our digital twin, so we have not made use of SAREF. But well, it's interesting to see that if you need something, if you need to include some inputs from sensors, then you can plug this SAREF solution to the existing kernel. So, but what will be this kernel? What we have in common what we have in common with the others, with HBIN and BIM2TWIN, with OMICRON also. This will perhaps draw the core system that we need at the end, all of us. Even if it's just case studies.
Sure. No, but I'm also thinking what Raul has mentioned about the methodology of how generate a graph database from the structured contextual data that you have from the asset. I think that could be an extremely good white paper. Yeah, it could be something really new and something that, because it's time that I'm trying to talk with the architects and engineers of my company about ontologies. They look at me like, wow, here and the guy is as always talking about, okay, that dreams. Okay, so, but something like that, I think, is something that is closer to the reality. Okay, because you are talking about something that they really know. Okay, which is using an IFC, potentially data coming from sensors, and how you are generating a graph data from it. I think it could be even something that we can even ask for help of Etsy or World Wide Web Consortium. I don't know. For example, Matthias from Neanix, he's also the chair of the working group of the bot in World Wide Web Consortium. So probably he would be interested in something like that.
Some topics like that, that's the point. We can even create a critical mass going to those places.
And this raises a really important question. I think that it was you, George, mentioning this maybe wrong. Okay, but do we need a mandatory graph database for a digital twin? Maybe that would be the first question we need to assess in this, or at least try. No, but I think when you are talking with an architect or a developer that has to pay for that, okay, if he's if this company is let's say the final customer, we need to convince this person that or this team of persons that that this effort is worthwhile.
So if you are interested in interoperability, you need.
Yes. In fact, the question, I think, is too quick. What we observed through the projects where we were discussing is that, well, it's mandatory to bring the various components, the various users to the same level in order to be able to make some reasoning on their data. And the best solution we have found today is this based on semantic technologies. And so the graphs are needed in order to apply some reasoning on them. That's why we are relying on triple stores and this kind of graph technologies. That's why we need them at the moment. I don't know if in 10 years there will be other solutions. But behind your question, you have this need of what was Raul saying. We need this interoperability, this understanding among these heterogeneous sources. And for the moment, the best solution is via graphs. And,
we have the introduction already. Okay, so I don't know if you have any other slide.
No, this is my only slide. It's a pity that we don't have anybody from ECTP because one question, well, during this morning I had a lot of questions, but they disappeared. How we can make a link or how we can influence with our critical mass the roadmap of ECTP. especially with this committee dealing with digital build environment. So.
With Alain.
So this is a question that we will put to Alain, and
so perhaps it's not too late to register to participate in the workshops that are starting next week
next week.
on the strategic research and innovation agenda. In the
Okay.
circulated requests for people willing to join the various the 3 topics they identified, for which they would rely on the existing white papers and try to revamp it with some experts or person willing.
Okay, good point, Stephen. Thank you. I was not aware, in fact. I see.
But of course, this digital question is a bit spread amongst the other topics. You might have different angles to it. And I think you can link to it from who is willing to some point to.
Sorry?
Who is willing to take the value to trade, which actually refers to who is taking value in the process. So when you discuss using data, so the ones that are producing the data today in the value chain, in the life cycle, I would say, are probably not the ones that are producing by contract today, are probably not the ones that will take the value afterwards. And that's what I think we need to map in the future also to see from what we need those data sets.
At the end, that's the key question. Okay? Who pays for that? Okay, so, and more when you are considering the whole life cycle. Probably at the beginning, the developer could be the, let's say, most interested. Okay, developer owner. Okay, because obviously a developer is when we are considering a new asset. Okay, but if we are including a retrofitting, okay, this is going to be the most interested people is going to be the owner and the occupant. That could be the same person. Okay, but obviously it's completely different because one is a professional, in the case of developer, in the case of occupant, when we are talking about my home, I don't have even users. Okay, and users that hardly can use maybe if it's an old couple, let's say, okay, it's going to be difficult even to have to manage with a computer. So it's going to be everything should be done by mobile phone. But at the end, I think when we are working those use cases are trying to extract the benefits. Okay, in the case, for example, of the ISO of the manufacturing, they have clearly stated the benefits. And what is clear is that right now the investments in digital twins of factories is being massive and it's exponentially rising. Okay, so I think the other day somebody was talking about NTT and NTT data. Okay, NTT, which is like the Japanese AT&T. Okay, and they are doing a massive digital twin of a gigafactory of BMW in the States. I don't remember which state. Okay, and it was getting all the automation, all the sensors. But obviously this is something that you can understand in a factory. Because if you are doing a digital twin of your supply chain, means that you are controlling the most important part of your asset, okay? And you are linking that with the manufacturing enterprise, MS, and the BM, how will you call it? You have the ERP, okay, which is enterprise resource planning, but you have the manufacturing resource planning. And you are linking that and the consumption of the energy, the planning, and you are linking all this. Okay, and you can make predictions and extract, improve. Obviously, this is something that really provides you a benefit, and that's clear. How we can get that in a more humble way, okay, in construction. Probably the speeds are different, okay. Mainly because we have in construction we have a lot of different stakeholders. Okay, in a factory, you have the boss of the factory, the owner is the same, and the rest just follow. Okay, in the case of a building, okay, you have subcontractors, you have people doing the manufacturing, tenants, occupants, owners, and a lot of more people related to that.
It's not related a lot to this one. In 1 month ago, something like that, it was published a document, so discussing something similar, but for interoperability. The document is called the Interoperability Imperative. And it's a report about interoperability in smart cities. And one of the recommendations that they give, if you want to have interoperability and sustainable over time, the thing is that you need to be from bottom to the top. So the big bosses need to want interoperability because they will have to pay for it. No, usually it's what Edward mentioned before. The technicians will like to play with things and do things, but this doesn't work. So you need to the decision from the top because you need investment. In the case of digital tools, to all the sensors to maintain sensors.
But at least I have the experience of in IDP. In IDP, thanks to the platform that we started to develop after one finish in a sphere, they were started in 2019, 2020 to sell services of digital twin. Okay, using our platform, and we succeed in a really short term. Okay, so I think that the aggregate sales of all those years is like 3 million. Okay, which in services that is a lot. But at the end, what we have found is it's something the CEO or the general manager that sees that as opportunity to control different plans, to control different assets, to see what is going on. Okay, but the people who is located in these places don't want it. Okay, because they feel like they have the big brother. Okay, so they don't want it. Okay, so they will try to put, as we say here in Spanish, to put all sticks in the wheels, okay, as much as possible. But beyond that, okay, we always, after all those years, we had the feeling that we are not trespassing the toy effect, okay, like, oh, amazing, it's really nice, we have all this information here, we have the 3D visualization, we have the sensors, but we are not providing a key added value, okay? A key benefit that will say, okay, I will keep updated the model. I will keep updated all this information because it helps me to save money. Okay? So if it does, we have not know how to sell it. But obviously, interoperability is a part of it, but also simulation, okay? And how to can make this prediction in terms of energy efficiency, in terms of predictive maintenance. Okay, if we are thinking in a more industrial environment. Okay, but obviously we are at the beginning of the road. Okay, so but what is clear is that in manufacturing in cities, they have been working a lot on that. Okay, mostly manufacturing and in aerospace, but also from cities. Okay, we can have, okay, discussion with them, trying to understand, and at the end, the aggregates are that, okay, we must be able to, if we have a digital twin of my green vehicle, my electrical vehicle at home, okay, and I have a digital twin of my battery at home and my solar panels, okay, I would like to include that of my home, okay, for a better functioning of the okay. But I remember when plug and play appeared, okay, that my computer science friends call it plug and pray, okay, so things take time. Okay, so just to wrap up, okay, because I don't know how we go in terms of time. I think it would be nice, first, if somebody has any question, or lunch is coming. If not, I think it would be nice, okay, to try to to set a couple of things, okay, as to do, okay? For, I think the first one for me is trying to generate this online workshop for September, okay, with all the sister projects, obviously inviting also OMICRON and other projects that might be, let's say, in this area, okay, that could be interesting. But I think the sister projects are interesting because we are at the end of the project with results, okay, and we see that we can share in terms of standardization. And afterwards, I think it would be interesting to generate a compiled document. I don't know what you think. Easy one, okay, like a compiled slide, okay, summing up or adding up your points with the points of COGITO, mentioning obviously which is from which one, and try to use that, okay, as a point of start for this workshop, and sharing that also with the rest of sister project.
Yes, for example, as in Asbin, they have made a lot of things for standard.
Yeah, so
It's useful to sit all of us together.
because in Asbin it's Austrian standards, which is inside, or it is the Italy.
Yeah, I think so. If you're right.
Yeah. Well, in any case, I think just with this document, which is okay, it's I think it's self-understanding, okay, and we can start with this, and I think in parallel we can try to think of this potential white paper of methodology, okay. If this could be a joint white paper of at least those two projects, okay, and asking also for the rest if they want to do it.
Yes, I think that COGITO and BIM2TWIN, we are ending almost the same time. It's April next year. But the two other sister projects, they are ending end of this year, around November. Because you get an extension, in fact. And well, for BIM2TWIN, it was planned since the beginning. But so we have
So
few
you are
months.
ending in November.
No. On the original plan, we were in November. But we requested an extension, 6-month extension for simulation and demonstration activities, which means that we will end hopefully at the same time with the April 2024.
Okay. But has been improved, do you know? If
I
they
think
are-
it's November
Yeah.
this year.
They are ending in November.
Yes.
Okay, then let's, maybe we can, do not delay them too much to September, we can try to do it in July, but I don't know, holidays is,
Yes, it will be difficult from BIM2TWIN side.
let's keep it then for, let's say, the second week of September, something like that. Okay.
Is there some event in September?
Sure.
Yes. There is always some events.
No, but if we can do it online, I think that.
Yeah, but well, you're totally right, Edouard. I think that perhaps we should also pay the coming year. I mean, it's not even a year now. It's another 9 months, remaining months. We have till April, till the next BDTA conference, to find some points where to progress and to meet with each other.
No, and it could be like a deadline, okay, this white paper, for example, could be done.
Yeah.
Could be sorry, this deadline. Okay, let's do that then. Let's share the document, okay, with the rest of let's try to prepare or to set a doodle to close a meeting in September. Okay, it's going to be done by me. Okay, let's say both actions. Okay.
Comment, because I recently been smart Poland, and I know that an Italian chapter, represented by Anna Moreno, from BB Smart Italy, during the meeting in Rome, this year there was a discussions between chapters how to count with the outputs not only that have been developed in the Building Smart, but also have been developed in the European research projects like this ones, to collect and to standardize or to come with these outputs to be used by the European Commission. So this is partially it's overlapping that we want to also do. Because you're thinking about the standardization results of the digital twin, how to standardize it, to put it in practice. So they also think about this.
Then let's work together.
Okay.
I've been talking with how is it his name? Dan. He's from Netherlands. He's leading the working group of digital twins of Building Smart. Okay, and I was talking with him in April. Okay, so and we agreed to talk soon. Okay, to see how we can align our actions. But honestly, I don't think if you are trying to impact the European Commission, that's good. Okay, that's the same like when we are talking about the ECTP. Okay.
Yes,
At the
I
end,
think that the right tool for that is the
Yeah.
ECTP.
Yeah, more than. And at the end, Building Smart is working in all the working groups. Okay, of the and actually the use cases. Okay, one of the core writing team, one of the persons is Midway from Building Smart from Germany. So join us.
But maybe we can invite them to this next
Sure. Sure. At the end, we were talking about critical mass. Okay, so
And there are a lot of people from this group that I mentioned that participated in European projects, so they also want to take these results from European projects that have been already participated to be used. So I can give later on contact and you can check if it's
Sure.
the same goal or not.
for sure, if you can give me the contact. Okay, so let's go for lunch then. Thank you so much.
Thank you very much.
So finally we can start. I would like to welcome all participants here, being face to face, and those who are with us online. And today on this workshop we will focus on the digital twin related technologies. In general, the workshops will be divided into two sections. During the first section before the break, we will focus on the digital platforms, digital twin data models, and as well we will try to speak about how to transfer data from the construction phase to the operational and maintenance phase. The agenda for today is that at the beginning we will have guest honor speaker from ECTP, Alan Zarley. And then we will follow with a very brief and short presentation from three projects that are related with the digital twin. We'll have the OMICRON, the project that is working on the digital twin technologies on the maintenance and operational phase with roads infrastructure. Then we will have two projects that are connected with the digital twin technologies on the construction site, on the building construction and infrastructure construction. And as I said, then we will have two short sessions related with the digital twin technologies, what technologies and services are implemented, to the platforms. Then we will speak about data models. And as I said, next topic is how to transfer data between those two phases of the constructions. Next, we'll have a Q&A session and the conclusion of the first part of the workshop. The second part after the coffee break will be dedicated to the potential of the digital twin technologies in terms of standardization and how to unify the standards of the digital twin technologies, BIM technologies, and other digital technologies connected strictly with the construction. So now I would like to invite Alan Zarli from ECTP for his presentation.
Thank you very much. Yes, should I stay here?
Yeah,
Okay. And just using this.
you can do those.
Okay, great. Okay, thank you very much. Very good morning to all. I have 5 minutes to introduce what we're doing in terms of digital twin in ECTP, so it's going to be a really challenge. So I will go very, very quickly on some aspects. On this one in particular, ECTP, as you know, is a membership organization. Its main key role is really to develop foresight vision and roadmaps for research and innovation in the construction sector and in the built environment sector. And what is interesting is that because, of course, ECTP is covering all the areas related to the construction sector, we are divided indeed in different committees. And in particular, there is one, which is the last one, on the right in the slide for you, which is the digital built environment, which is indeed dedicated to all aspects of digitalization of construction and the built environment. And in this context, like for the other committees, we indeed, on a regular basis, develop position papers that then are used indeed to identify at a given point in time, every 3 or 4 years, what are the new key trends and challenges, what are the high-level objectives that we want to tackle in terms of digitalization for the construction sector, what are then the research and innovation needs. We try to identify also the connection with other ECTP committees and other topics, as well as external initiatives. And this, of course, is to feed the ECTP strategic research and innovation agenda. And so we had a new position paper indeed in 2022 at summertime, and we finalized it. And one point which definitely raised is related indeed to this concept of digital twin. The idea is really that our view on the digital twin is that it is going to be a real dynamic view of, but under, of course, a virtual view, under a digitalized form of what is the reality around the buildings or, of course, around a district or a city. So it's, of course, considering including all the BIM aspects, and you are all familiar with that, but it's also the need to extend to BIM data management with all dynamic and evolving management of building related data, the need to network sometime or link data among them, and the need to deal with semantic integration of external knowledge. And that's something which is very, very important for us. And that is indeed supporting the objective of the Build for People partnership, which is focusing on other areas, in particular energy, decarbonization, and circular economy. But of course, digitalization is instrumental in achieving these objectives. So, roughly, for us, the key components of a digital twin system are based on the physical, virtual, and data linking elements of a digital twin. And that should allow, of course, to do at any time on this evolving and living digital twin, embedded simulation, optimization, applying artificial intelligence mechanism, and potentially developing smart services on top of those digital twins. And that indeed really corresponds to the identification of the key components for digitalization. You can see that indeed we divided in two things, but definitely there is this notion of semantic digital twins also in relationship with cognitive systems. And what is very interesting for us in this context is that we are also interacting, ECTP, with two other associations, which are key in the development of those elements, which are the Building Digital Twin Association and the AIoT, dealing with all aspects to Internet of Things. So, just very, very quickly in a nutshell, and I'm very, very sorry because, well, this is disappearing in a different color, but you will be able to see it nicely on the slides that will be made available, I guess, to all of you. But overall, among those key identified trends, digital twins, of course, was one of the key assets, considered the key assets. And the position paper of the Digital Built Environment Committee have identified 6 objectives. I'm sorry, but I'm not getting to detail everything of it. But what is interesting is I tried to put in red, where there is explicit reference to digital twins. And what is very interesting is that in all of them, in all the objectives, there is obvious reference to digital twins for renovation and new building, for definitely dealing with simulation combined with real-time monitoring, or integrating in a life cycle perspective. You have also other aspects related to dynamic data that could feed, of course, and complement all the information from the BIM. You can see on this one that, well, the digital twin is supposed to support all decision-making systems. In that case, it's also trustworthy AI solutions on top of digital twins. So overall, you can see that in all the high-level objectives that have been identified by ECTP in the Digital Built Environment Committee, there are references indeed to digital twins. So definitely, this is a very, very hot topic. And this makes sense, of course, to have several sessions on this topic in this conference. Just as an example, and I asked one of our members who is very, very active, this is not the only one, but for instance, List in Luxembourg is very active, for instance, in applying BIM and digital twin for consolidating data semantics in the context of the life cycle assessment. That's one example, and the project is called Semantic LCA. And there is another example, which is about how to move from BIM to digital twin to achieve a monitoring and assessment of facade component tests. So those are, for instance, 2 examples that are used in 2 different cases. And Sylvain Kubicki, who is just here, will be, I guess, quite happy to discuss with you about those developments which are ongoing in this. So this is one example among others, because I didn't get time to do more. Indeed, there were no time to do more. We also there is also an interesting book that was which was written last year about buildings and semantics. And on one chapter, indeed, we really try to detail a little bit a view on digital twins for the built environment, and this is coming also from ECTP members. So I will stop here, and I would like to thank you for your attention. It has been a little bit quick and squeezed, sorry for that, but I was supposed to do it in 5 minutes. But definitely, from the ECTP point of view, digitalization is key. And inside digitalization, we really identify development of future semantic digital twins associated with cognitive systems to be instrumental, of course, in supporting and solving future problems for construction, for renovation, and so on and so forth. Thank you very much.
So, thank you again, Alan, for the presentation, and it's important for us to having ECTP as a support for our projects. And now we will start the session presenting the projects, and we will have now Naomi Jimenez presenting OMICRON.
Okay. So hello, good morning, everyone. My name is Noemi. I'm going to present the OMICRON project. OMICRON is an Horizon 2020 project coordinated by by CEMOSA and participated by all the partners that you can see in there. In here, I would like to emphasize that in our consortium, we have all the elements in the value chain. We have research institution and technology developers, such as University of Cambridge, University of Seville, CATED, but also as technology developers, CEMOSA and Indra. We have ICT integrators, such as Regen, dissemination and communication expert, which is ESKI, road contractors and civil engineering experts, such as CEMOSA again, Armando Rito, Teixeira Duarte, Faso Pavasal, and then we have road operators and owners, such as Autostrade per l'Italia. Okay, the OMICRON project is develop an intelligent asset management platform for road. It is structured in 4 pillars. Firstly, we have a block on digital inspection. In that regard, we cover inspection by means of drones, and also we develop a set of technology embarked on a terrestrial vehicle for inspection of the pavement. In addition to that, we also develop V2X communication to allow communication between the maintenance crew, the control center, and the regular road users. With all this digital inspection, as well as the information coming from the legacy system, we develop a digital twin of the road. And this digital twin of the road is a virtual replica of the physical asset, and it's totally updated. We use the information from the digital twin for our decision support system. In our decision support system, we do assessment of road condition, diagnosis, forecasting, and we also define which are the best maintenance intervention in order to keep the road in a safe state. And we also develop the algorithms to optimally allocate the maintenance intervention, keeping the costs, minimizing the costs, and maximizing the level of service and the safety, etc. In addition to that, in OMICRON, we also include some smart construction technology, such as a development for modular prefabricated, and we also provide robotization and automation of some intervention action. So all in all, with all these blocks, we achieve the impact that you can see in there, which are the reduction of fatal accidents for a maintenance crew and for regular road user, the reduction of traffic disruption because of better maintained roads, the decrease in maintenance costs, and also as a consequence, an increase in the capacity of the network. So I would like to emphasize that the digital twin covers the whole life cycle of the infrastructure, covering also the design you mentioned. It has a lot of development for the operational maintenance, but it also integrates the design. So thank you.
Thank you very much. So now we will have the COGITO project presented by Georgios Giannakis.
So, hello everyone. COGITO in a nutshell, and back in 2020, when actually developing the COGITO proposal, a thorough desk search revealed that the construction phase had been overlooked by the digital twin community. Where actually many studies showcased that the lack of commonly agreed standards and low interoperability among the collected data were considered as major drawbacks for the enterprise's digital twin transformation. Delving deeper into the source of the problem and trying to find solutions, ways to address those drawbacks, we witnessed that the need for going beyond the static building information modeling, where actually technologies like IoT, data, cloud computing, and AI should be leveraged. And actually the need for a transparent digital twin platform for the digital data handling, where actually BIM data are fused with IoT data and digital twin platforms, digital twin application results to foster the efficient and sufficient collaboration between the many parties involved in the construction phase. Actually, this is strongly related to the development of a common data model, and actually it's an ontological representation, which actually is the backbone for the development of the digital twin, such a digital twin platform. So, to that direction, the COGITO consortium consisted of the 13 partners that are depicted on this map. Promised and managed at the end to develop and deliver a digital twin management platform like the one that I mentioned before as a need, and a digital construction for toolbox that constitutes to the productivity improvement and increased safety. So, in more detail, I'm going to present the individual components later on in the next session. But in more detail, actually, the COGITO solution relies on many components that have been delivered by the COGITO consortium. And we see here that in the middle lies the construction digital twin platform, which actually is the main component, the main data management component, and the ecosystem that allows the other components to feed data and consume data from that data management system. On the left side, we see what are the actual sources of our solution. And we do have the as-planned data that are taken for granted, and reality capture tools that acquire all the data that are required by digital twin applications, and are being pre-processed to be curated and being uploaded to the digital twin platform. On the right side of this figure, we see that we do focus on four main domains for digital twin applications: the health and safety, the quality control, the adaptive workflow management. Last but not least, we are also developing and providing rich graphical user interfaces and supporting applications to elaborate the communication and actually provide access to the end users to the results that are developed, that are generated by the individual digital twin applications. So that's the COGITO solution in a nutshell. Details on the components, the specific components that were developed, will be seen in the next session after Bruno is going to present the BIM2TWIN project.
Thank you, Bruno. Now, project BIM2TWIN from Bruno Fies from CSP.
Thank you very much. So good morning to all of you, and thank you to Noemi and Georgios, because they have already introduced most of the things that I will present you. So I'm Bruno Fies from CSTB, coordinating the BIM2TWIN project, which belongs to the same core as COGITO. So you will see, I think, some similarities. So the aim of BIM2TWIN is also to focus on the on-site activity, and is to provide a digital twin solution in order to follow up what's going on site. And this is done between a continuous comparison between what has been planned initially, so what was the initial BIM, what was the initial planning of the activity on site, and the comparison between these two inputs and what's going on site. And what's going on site will be follow-up by acquisition, reporting, and so on. So we will focus especially on volume monitoring, what has been erected, where it has been erected. Is it at the right place, the wrong place? Is it in the tolerance of the construction norms or not? Also some control about the quality of the construction. We will follow up also the states of the surface, Is it painted? The tiles are there or not? Totally, not totally, according to the schedule, and so on and so forth. So, and of course, we will mix that with some health and safety aspect in order to protect the users or the workers on site. We are a consortium of 17 partners with a wide vision or extended vision of Europe, because we have also 2 partners that are in Israel working with us. And this is my only slide. So I will present you our components, our platform, and the various services that are connected to this platform in the next session. So,
Thank you very
thank you.
So as said at the beginning, now we will start a sub-session related to the digital twin platforms and services to speak about technologies implemented in the platforms. The first project will be OMICRON.
Okay, so as I said before, OMICRON developed an intelligent asset management platform for roads. It covered the whole life cycle, and in here you can see what we integrate in our platform. We integrate developments coming from smart construction from the construction phase. We also include technologies from digital inspection as well as information from the legacy system. We also do development to support the execution of maintenance intervention, and we also have a relevant module for the predictive maintenance for the decision support system. So I will go through the different pieces of this platform. So as I said, we also cover the construction phase. So our digital platform is able to integrate information from the construction phase. In particular, here we have a use case where we do some modular construction development for using prefabricate for bridges, for road overpasses. We use prefabricate because it's reduce the construction time, reduce the traffic disruption, improve the safety, and improve the circularity. What we do here, we design a piece for the better connection of the concrete and the steel part. And so the stages that we follow here, first we do some monitoring on similar bridges to understand the problem. Then we do some designs and do some land testing, and finally we are in the last stage now. We are finalizing the design, and now that design is going to be integrated into the digital twin platform. We have a relevant part of our platform is to integrate information coming from digital inspection. Here we have inspection coming from drones. In that part, we work on multi-UAV inspection and also in long-range capability, working on the tech-enabled system. We also are developing an innovative combination of camera on board of the commercial vehicle for a better assessment of the pavement. And as I said, we also develop B2X communication to allow the communication between the maintenance crew, the control center, and also the regular users. As I said, we also develop robotic and automation procedures to facilitate the execution of a variety of ordinary, extraordinary, and emergency maintenance action. Regarding robotization activities, we have developed a robotic modular platform to perform all the activities that you can see in there, such as safety barriers replacement, safe signaling during construction, installation of cones, sealing of pavement cracks, cleaning of assets, removal of lane marking. And we are also working on the automation of the process for the rehabilitation of pavement. In this second part, we need to integrate a variety of sensors, and we also provide support in relation to the process. In this use case, we are using asphalt for ultra thin layers and recycled asphalt just to make it greener for the environment. We, in addition to the robotic activities, we develop augmented reality tools to support the workers in the use of the robotic modular platform, and we also develop virtual reality tools for the remote operation of the robotic modular platform and for the training of workers. And finally, you can see in there the core of OMICRON's digital twin, which is composed of the digital twin itself and a road decision support system. In here, you can see a visualization of some development that we have for our digital twin. In this case, these developments are done in a platform developed by FEMOSA. It is not totally the OMICRON project, but follow the same procedure. So in our road digital twin, we integrate the variety of information that we have. It is based on a BIM GIS environment. And it allows the integration of all the information and provides analytics capability. And then we have connected to the road digital twin, we have a decision support system which assess the road condition and forecast the future state and suggest the best maintenance option and optimize the allocation of maintenance tasks. I think that's it.
Thank you, Amy, again for the presentation. Now the floor goes to Georgas and COGITO.
Okay, so actually on this slide, we see something like a conceptual data flow between the components that were developed within the COGITO tools, actual tools that were developed within COGITO. And I've also tried to introduce briefly the various components and number them as well. So starting from the left of this conceptual, let's say, diagram, we have at the bottom the as-planned data. Here, as I mentioned before, we are taking the as-planned data for granted. What that means? Actually, we have developed precise guidelines to guide the BIM modeler on developing a BIM model that fulfills the requirements of the project, and actually provide us with an IFC file that has all the metadata necessary to enable later on the digital BIM applications to run and produce results. Apart from the as-planned data and the BIM model, we also have the scheduling information, when activities start, end, and so on. Also for this part, precise guidelines have been developed and provided to the end users, the stakeholders, and both guidelines documents have been consolidated in one version that is actually, if I'm not mistaken, yet available. It will be available on our website as well. Apart from the as-planned data, we do have the as-built data. For the as-built data, we do have two different, let's say, groups of as-built data. The point clouds and images that were retrieved on-site through laser scanning or with regular cameras and so on. And we do have the IoT data, where in our case, the IoT data are considered only the location data of resources and heavy machinery. Actually, these requirements were actually developed, and we ended on those requirements based on various discussions that we had with the tool owners, developers, and the stakeholders. The part of the point cloud and the images data are being pre-processed so as to annotate the data that are acquired on site with data that come from the BIM information, so as to link somehow those data with the data that are coming from BIM. Something similar happens with the IoT data pre-processing module. It's the second component, where actually we feed the digital twin platform not with raw data acquired from site, but curated data. You know, it's quite often that IoT sensors have somehow noisy data that should be at first filtered and then fed to the digital twin platform to be consumed by digital twin applications. Up to this point, we've touched upon the data acquisition and how we feed those data. We feed the digital twin platform with those data. So, three main components have been introduced: the visual data pre-processing, the IoT data pre-processing, and the digital twin platform. Moving to the digital twin applications, we have a group for the health and safety, where actually we are introducing two main components, tools, the SafeCon AI and the proactive safety. For the quality control, we have the geometric quality control and the visual quality control. And for the workflow management, we have the process modeling and simulation, the work order definition and management, the service level agreement manager and the blockchain smart contracts, and the work order execution application. We'll see details on those components in a few minutes. So, based on this information flow, conceptual information flow, we put a lot of effort to actually develop the architecture of the COGITO solution, where the interactions between the various components is detailed. And actually, we developed use cases, we developed sequence diagrams that actually present for each use case the interactions between the various components. And actually, we decided at the end that to make more reasonable or more simple the conceptual architecture of the project, we should split the conceptual architecture in two phases: the construction phase and the planning phase, where several components are involved at each phase. I know that you cannot read the text here, but it's quite tough, and that was not my intent. But it would make sense if we find the architecture and the details in the architecture quite interesting for you to access the relevant deliverable on our website. So let's see the components in more detail. I'll try to be quite brief, and I'll start with the digital twin applications for health and safety. On the left side, we see the SafeCon AI tool, which is actually a tool that's applied in the planning phase, and it's for the preventive health and safety, where actually we take as input an unsafe BIM, actually the output of a BIM authoring tool that was developed following the guidelines that I mentioned before. And then using specific algorithms that run on backend, this input file is being enriched with safety elements. In the video that was displayed, actually we saw how the algorithm detected hazardous areas, fault zones, and placed on those zones safety elements like railings. The second digital twin application for health and safety is actually the proactive safety. We call it proactive safety, and it's an application for risk detection and alerting, where actually the specific component takes as input the safe BIM that was delivered and exported from SafeCon AI, and combined with location data that are acquired on site to detect proximity in hazardous areas and alert the end users through specific devices that they are wearing. The third digital twin application for health and safety is named virtual safety, which is actually not intended to be used for the planning phase or the construction phase, but as a means to educate the relevant end users and stakeholders, workers, for example, to avoid any hazards on site. So we're talking about a virtual reality environment. We're actually putting some smart glasses. The user can walk through the construction, the virtual environment of the construction site, and based on his performance, we provide at the end something like a documentation with regards to his or her score, what he could avoid or not, and other indicators that are relevant to its performance with regards to health and safety. Moving now to the quality control, here we have four main components. At first, we have the visual data pre-processing app, where actually, check if the video is running. Yeah. Do you have access on mouse? No. Sorry for that. Maybe I can show you the video afterwards. What is the visual data processing about? Actually, it's a web application to curate the visual data that I mentioned before and establish somehow the linkage between the BIM elements and the data that are required on site. For example, when we scan a specific area of the construction site, we do need to know how this scanned area is linked to specific BIM elements that are being captured in IFC format. So this is the tool that is being used for curating this data. And actually, apart from link the data that are acquired on site with the BIM data, there are other ways to also process the images so as to ease later on the use of defects in detection and inspection. Apart from this app, which is meant to upload the data on a digital print platform with regards to visual data, we do have two. Yes.
May I have 1 moment to check one thing with the
Yes.
Sorry.
So, as I was saying, apart from the visual data processing application, the web application, we do have two backend services. The one is the geometric quality control, where actually it receives as input the scan, the point cloud data, and the BIM model, and tries to detect any discrepancies, deviations from the tolerance with regards to quality control checks that are coming from regulations. Okay. And apart from geometric quality control, we also have the visual as a backend service, the visual quality control, which actually runs some deep learning algorithms on images that are acquired on site and tries to detect defects and the severity of those defects. And last, We do have the digital application, which is actually an application that was developed to run on HoloLens 2. We're actually using the smart glasses on site. The inspector, let's say, could or surveyor could go through the site and see annotated results from the geometric quality control and the visual quality control, and confirm the existence of such quality control results. If, for example, some defects were detected, they need somehow to be confirmed by an expert. So we put points on where those quality control defects are located, and then the expert should visit the specific area and confirm that this defect exists actually. Next group of digital twin applications are digital twin applications for workflow management. Here we have three main components. The first one is the process modeling simulation optimization, where actually we define the details with regards to the workflows, the tasks that its workflow involves, but also optimization services, where actually through optimization algorithms that run behind the scheme, we receive information about the optimal number of resources, where those resources should be allocated, if which is the critical path, all this stuff relevant to optimizing the schedule and actually minimizing the time and cost of the construction project. Apart from the PMS tool, we do have the work order definition and monitoring tool. Again, it's a web application. We're actually taking as input the result of the process modeling and simulation environment and optimization result. The user of this specific tool tries to assign real resources, specific people, specific equipment, to specific tasks, and so on, so as to be able to be monitored. And through this application, you can monitor progress on specific tasks and activities. And actually, we do also have the work order execution assistance application that runs on mobiles, but also on smart glasses. And actually, this application is the way that we provide the mean that we provide with the end user to report progress, completeness of a task, and so on. But also, if he notified anything that is quite important and should be reported, relevant to a specific task or activity that was assigned to him or her. And as we mentioned before, all the data handling and the communication between the various components that were developed within COGITO are managed by the digital twin platform. So actually, the digital twin platform is the core of the COGITO solution. And actually, for its development, we follow UCL, was leading this effort, in collaboration with UPM, who actually developed the data model and actually the ontology required. And actually, we followed a multi-layer architecture here, actually a 6-layer architecture, consisting of the authentication layer, where actually this specific layer ensures that the access to resources and applications as end users are limited only to the one that has access to these specific applications or resources. The data ingestion layer, which is actually the layer that is responsible for loading the input of data through the digital twin platform but also run the quality control for those data, the quality control checks, the model checks, the model completeness, correctness, consistency checks, but also the generation of the knowledge graph. The data persistence layer, where actually we do have a unified cloud-based solution, including the databases like relational, key value, time series, triple store, and so on. The data management layer, which is actually the layer that is responsible to reply to requests for data retrieval from the digital twin platform, and actually serves as the main provider through this layer, the digital twin platform, to the other applications of our solution. The data post-processing layer, which actually process BIM data, and we'll see some examples later on. And the messaging layer, which is actually transmitting all the messages and notifications that are necessary for communication between the other COGITO tools. And here are some, let's say, it's a collection of screenshots taken from the digital twin platform individual components. We do have the knowledge graph generator, which actually performs the generation of the knowledge graph based on data that are loaded in this platform. The input data management component, which actually provides a graphical user interface to create a new project and upload the as-planned data that, as we see before, the as-planned data are taken for granted. So there is no tool to generate those components. We expect the end user to upload those data. The different databases that are considered as part of the persistence layer, and the digital twin library and the digital twin runtime, where actually we do have something like actors-based approach with regards to the development on how modules, actually tools, other tools in the COGITO solution run and exchange data through the digital twin platform. And with regards to the post-processing layer that I mentioned before, some examples here are the BREP generation, actually how the IFC information is converted to OBJ files to be imported in graphics and readable to Unity images, for example. The geometry class checker to detect classes between elements if there are any. The IFC optimizer, where actually we take the IFC file and try to reduce its size, but the resultant file is consistent with the IFC schema. And how we perform the model view definition checker as an individual component to ensure that the data that were provided in IFC are complete and complete with regards to the data requirements of the project and consistent with regards to the IFC schema. This is my last slide, and sorry if it takes longer than expected. The last tool is the visualization application for all the data that are collected in the digital twin platform. We call it DCC, Digital Command Center, and actually it's again a web application developed in a Unity game engine. And actually, the different results of the results of the different digital twin applications are displayed in different overlays. Where we do have the quality control overlay with regards to the quality control results, the health and safety overlay with regards to the health safety application results, the location tracking overlay with regards to location data, and finally the progress, the workflow management application results in the word overlay that you see here. You do have also the possibility to filter the data through this user interface based on the as planned data or the as built data. So maybe I'll go. And, the video was about that. So I'll skip the video and we can see it later on my machine, okay? If you are interested. So that's the end of my presentation, and those are the various components that were developed within COGITO so far, and we are currently under the evaluation and demonstration of those components in two real construction projects, infrastructure projects. The one is located in Munich, and the second one in Murcia, Spain. And that's it for me. Thank you.
So can you please take the floor? And now we will see the details of the BIM2TWIN project.
Okay, thank you. Well, these presentations raise a lot of questions, at least from my side. I'm trying to note them. That's good. So before starting, trust me, when submitted the BIM2TWIN proposal, we have not copied on COGITO documents, I swear. But, okay, as I said, so we are here in BIM2TWIN focusing on site activities for buildings, and our main components are there on this slide. So first of all, we have the platform, the digital twin platform, where several services are connected on top of it. These services are either pre-processing the data and post-processing them, as also George has mentioned it. And well, as input, we are taking into account, of course, what I was just mentioning at the beginning, the as designed and as planned projects, so BIM files basically and plannings. And we are putting that into our platform. It means that we are translating IFC files or MS project files into graphs because the underlying technology is a linked data technology, so we are based also on triple store solutions. And then, when the on-site activity is going on, we are following the state of the activity through data acquisition. That means people are visiting the site and are noticing some status. We are doing some acquisition via LiDAR or cameras. I put here drones, but in fact our pilots are too close to sensible areas and we were not allowed to use drones. So we relied on the terrestrial cameras and LiDAR to perform some acquisition. So we are playing with mainly images, static images, videos, and point clouds. So, and we have in BIM2TWIN these 5 services, the colored boxes you have on the right-hand side. So we are focusing on volume control and process monitoring, surface control, and of course process monitoring, also safety control. And we are sharing with COGITO the same partner that is dedicated to the safety aspects. That's why we have de facto very some similarities. We are also working on the equipment optimization and the production planning also, which is more the follow-up of the planning and the proposal for new planning, taking into account the real activity on site. So our core platform is something that is developed by one partner, Orange. So it's based on one of their tools that is called Fingin. So it's their layer above a solution that is ArangoDB. And so they have developed an API on top of it in order to allow us to inject our data to this triple store. And connected to this platform, we have a dashboard. It's a kind of high-level dashboard providing either KPIs that provide a high-level view on the status of the project or of the construction by itself. And there is also a 3D view that allows us to follow what's going on, where are the defaults, and so on and so forth. And of course, this core platform is coming with internal data models that allow us to link the construction, the planning, and the input files that are coming from the acquisition provided on site. I will now go through the different technical services that are connected to this platform. The first one is dealing with volume control and process monitoring. So we are working with point clouds that are performed by leaders. So it could be a static acquisition, or it could be somebody that is walking through the site and acquire at different time the status of the construction by itself. So there are some pre-processing activities. So it means that people are playing around with these point clouds in order to recognize some objects. Mainly, they are focusing on columns and walls. And after that, having recognized some objects in this point cloud, they have to match what they have recognized with what it is supposed to be from the initial BIM file. So there is also here some algorithm in order to perform this recognition, to also test if what has been recognized is really matching what is supposed to be erected at this place. Is the accuracy of the acquisition enough in order to say, yes, it's a valid column, it's a valid wall compared to what was expected or not? Well, so you can imagine that these algorithms are based on learning techniques and with some little bit of artificial intelligence, let's say. And everything is connected to the dashboard, so to the platform, of course, and then to our dashboard in order to say, okay, I can update with this acquisition, I can update the KPIs concerning the quality of the volumetric aspect of my project, and I can also display on the 3D part of my dashboard where are the columns that are effectively erected at the right place, or the defaulting ones that were not erected or erected at the wrong place. The second service is about surface control and process monitoring. Well, I didn't put words also on the process monitoring aspect of the previous one, but you can imagine that as long as one column is detected as a defect or having a defect, it has an impact on the task belonging to this column, or the column is belonging to a task, and then there is also an effect on this task, and that has also an effect on the last service that I will talk to you about, the planning optimization. So everything is linked. And here, so going back to this surface control and process monitoring, we are not working with point clouds, but we are more focusing on image processing. So we have developed image recognition techniques in order to identify the built objects. like you can see on this picture. And the idea here is to say, okay, I can recognize that there are rebars. So it means that, okay, we have started the construction, but it is at an initial level. We can see also there are some of these columns that are already done. It means we are at higher states in the construction. We have progress, and in between you have this middle status here, where it's, I don't know if there is some pouring concrete in it or not, but well, it's an intermediate status. Also, in this activity, we are focusing on surface default, like cracks, honeycombing, and things like that, where we are able to recognize that through images treatment that they are default on the surface. We can recognize where it is and link that again to the corresponding object in the initial BIM file, so in the as design model, and raise the fact that there is a problem here. So the corresponding task will be delayed. So there will be an impact in the global planning concerning that. About safety control, we are here. So George, you already talked about that. So it's a same partner that is providing an app that is connected to our platform, the SafeCon AI, that is able to dynamically generate safety components and add them to the initial BIM. And for us, they are calculating also safety related KPIs. The idea is then once they have generated these components, is to inject them back to the database in order to be able to display them on the fly through the dashboard. This is an ongoing activity, but also as long as they are providing this information that we need to erect or to put in place some guardrails or safety equipment, it means that it will require time, task, effort to do it. So it is also injected in our platform in order to be taken into account by the planning activity, the planning monitoring that I will talk later. So we have also a service that is specifically focusing on the equipment optimization. So it is based on image and camera recognition, where the activity of equipment is recognized. So they are working on trajectory calculation in order not only to optimize the use of these big trucks and equipments and heavy equipments, but also in order to cross this information with safety information in order to analyze if the trajectory are going too close to a worker's area and prevent them from risk when working. So again, this service is working with animated images, so camera is working from videos, and is linked to the safety component in order to optimize not only the equipment but also the safety of the site. And our last technical component is about production planning. So it's a software prototype for the moment, and the idea there is to based on some simulation to really provide what we call alternative plans, possible plans for the future that are taking into account the real life, I would say, of the on-site activity. I was just talking about the interactions that are existing between the other services and this one, and just to tell you that, well, when they are performing one simulation, it takes approximately one night, 8 hours. So it is something that is quite complex behind this simple, I would say, dashboard here that they have developed. There is a lot of things calculated behind, and we can decide at the end of this calculation what will be the new plan for the site, and then it will be injected in the DBT in our platform as the new plan for the project. So a few words about the dashboard. So we have this 2D dashboard that is providing KPI high-level information based on the calculation of several KPIs in order to follow the on-site quality, I would say, at a high level, at a very high level. And we can also, there is a 3D part. We can also display. It's a logical view. I mean, it means that it's based on the as designed BIM initially, that is translated into IFC all and in a rough view, I would say. But here it's based on a IFC GS component, and you can see where are the defaulting columns and walls, for instance. There are several possibilities. You can see, well, give me what was erected between that date and that date, and so on, in order to follow the progress of the construction of the building, and also to localize where the default occurred and when. And I think that is all for me.
Just before the presentation for Omicron, I would like to inform that we had the delay at the beginning due to these technicalities. So we will have an additional 15 minutes for our first session, as we're supposed to finish in 7 minutes originally. But due to the problems with the computer, we will extend the workshop, the first part, 15 minutes. And now we have like 20 minutes. So my proposal is to stick with like 4 minutes per data models, to left a few minutes for the discussion and questions. So now each project like 4 minutes.
I'll be quick. And also I need to be quick because I need to be in another session presenting something else, so I cannot be very much delayed. So I will explain about the data architecture that allows in OMICRON project to have a digital twin as a virtual replica of the physical twin. So you can see here the structure. First we have the physical layer to integrate the information coming from the physical twin. So in here we have information coming, for example, from inspection, monitoring, also from the stage of the execution of maintenance tasks, traffic information, and another. Then we have the integration layer, which allows the transfer the information from the physical layer to the inner part of the database, and it has to load to get the information and transfer it and send and upload into the appropriate data repositories. Then we have it is a pity because the quality is really bad of the slide. You cannot see anything, and in here you can see the different tools and methodologies that we are using. It is a little bit of a pity. Then we have the data management layer, which is a graph-oriented database, and I will go into it in the following slide. Then we have the digital twin layer, where we have the digital twin products such as BIM classes and instance, BIM classes, instance, and products, and they are based on IFC standard or CTGML. And also we have the digital twin processes, which are those providing the analytics and which are extensively used by the decision support system. And finally, we have a user interface layer to show the result to the user and in a BIM GIS environment. So as a general goal, this data architecture allows the integration of a miscellaneous type of information, including digital and legacy system. It enables prediction capability, simulations, also for the decision support tool and visualization in a very nice platform and very much business oriented. In here I can have some more details of the data management layer. In our project we have a variety of data. We have dynamic data, such as, for example, the accelerometers in the bridges. We also have asset management database, including also information for the legacy system. We have static data from the geometry and the classes, and we have a variety of documents. So this information is stored in time series database, relational database, file system, and document management system. And then everything is orchestrated in a choreographed database that organizes all the, where the information is centralized and the different hierarchy around the different elements is provided. And this graph database is based on an ontology which has been developed in the OMICRON project and using as a reference IFC, also IOF maintenance, and also IDSA. Yeah. And so I have explained the state of the platform, the data architecture. So for the moment, we have already implementing the architecture and the data model. Everything is ready, and now we are working on the decision support system. In particular, we are working on the decision support system for the prediction of degradation of pavement and maintenance of those pavements. We also have a use case on structural health monitoring on bridges, and we also are working on optimization algorithms for the optimal allocation of maintenance payments. And that's it, very quick.
Okay, thank you. Accurate. So now COGITO will be presented by our host representative, Raul from BIM.
Good morning, everyone. So you have already seen that we have a lot of components in COGITO, okay? And the way we manage semantic interoperability between these components is, as we have mentioned, through the digital twin platform, okay? You can imagine that for each of the use cases, among 5 to 10 components have to interchange data in order to solve the use case, okay? So for that, we need to enable semantic interoperability between these components, and we have to ensure, so these components work asynchronously, so we have to ensure in every moment that when we ingest data and we create the knowledge graph, we have to ensure the validation of this data, okay? This is another thing that with the ontology, we can make sure that whenever someone needs the data is in the correct shape. We have the things related to the validation. We have, so I'm trying to focus on the things that are different, okay? So not on the things that most of us have in our projects. Another thing that for us is very important is all the things related to the provenance of the data. Okay? We are extracting data from IoT, the work plans, and so on. We have our knowledge graph, but we always provide to the users, okay, the provenance of the data with the pointers to the raw data where the data has come from. So if we detect that there is a defect in a column, we can provide the users in an automatic way the pictures, for example, that indicate this defect or the worker or whatever. No? And I'm just talking, ignoring the slides a bit. And the other thing that I think that we have and that is different in COGITO is that a part of the semantic interoperability based on standards inside the platform, we are interested in providing interoperability with other platforms and systems, okay? Enable integration with them. So for that, all this information can be accessible in the knowledge graph and in the platform to third parties using standards and using semantics. Okay? So a third party can ask a third party, a person or a machine, can tell, okay, which digital twins you have in the platform? Where are they? How can I access them? So we can even automate the access to this information, okay? And support interoperability with other systems that are not controlled by us. Okay? And I think that this is the main part. So we are following, for example, for all these part related to external access, we are following the Web of Things approach in the W3C. We are using the self ontologies, IFC OWL. So we are, of course, based on standards, okay, in our approach, not only at the data model level, but also at the protocol level, at the data access level. And all the things that we are producing, everything is available, openly available in the COGITO ontology portal. So anyone can go there, use our ontologies, contribute to them, validate the data. No? If they want to access data through an API, here you can go and check the information so you can validate on your own if the data that you are receiving from us is correct or not. Okay? You can contribute, give feedback, and so on. Very fast.
Thank you, Raul. The final data models.
I will try to be quick. Okay, the conditions are very similar to the ones that were cited by Raul. We have at least 5 different services. We have to make them talking to each other, taking into account also the fact that we are in a building environment, taking also into account that we are dealing with IFC files, we are dealing with plannings that are coming from heterogeneous sources, and so on and so forth. So we have set up different data models for that, and the idea, in order to elaborate this data model, was not to start from our own issues, but just also go through the existing models, the ones that are standardized, in order to, well, like when we are doing our shopping, taking what was interesting for us from them, because it was already done, and we have been reusing most of the existing ontologies for our needs. We also double check that with the end user, taking into account what was their needs in terms of words, concepts, relationship among them, and so on and so forth, in order to grab their vocabulary, the way they are expressing these things, and link these terms to the existing concepts that were present in the ontologies and the standards that I was mentioning in the previous slide. And together with this top-down, bottom-up approach, we produce our models. Well, this is a list of existing ontologies and standards, so I can skip it because it will be there will be another discussion from that, and that's it from my side. So very quick.
Thank you. Okay, so here is another part of the workshop today. So the discussion and let's say about the transferring data between different digital twin technologies, and how to ensure the connectivity between the construction phase to the operational one. And let's move on.
Okay, I have a slide in there.
Yeah.
Yeah, and I just wanted to mention and to emphasize that our platform is suitable for the whole life cycle, including the construction phase. So, because our digital twin is based on the information that we have from the design phase, the planning phase, and then the construction phase. So we always, our digital twin is a virtual replica of the physical twin, and so we incorporate the information from the construction phase. So what I wanted to express here is that we think that, of course, the digital twin, because it's a twin of the physical asset, it needs to incorporate the information from the construction phase, the operation phase, and the maintenance phase. And so in here, I just wanted to emphasize that in our case, OMICRON, the decision support system is focused on the operation and maintenance stage. But we are working in CEMOSA toward the evolution of this platform to a more comprehensive one, oriented toward the improvement of the sustainability, aligned with BIM goals, and to the improvement of the resilience to extreme events. And also we are working on the development of governance models for critical infrastructure in extreme events, because for those infrastructure in a hazard condition, we need to align very well the different stakeholders dealing with the infrastructure. So, in my opinion, the digital twin covers all the phases, and my point here was to emphasize now the sustainability, the resilience, and the governance of, in particular, critical infrastructure.
So, we have received one question related to this. Is there any specific data transformation or conversion process required while we are speaking about transferring those data? This is the question. Is there any specific process needed for those data transformation?
What's the question for?
For audience or for you, as you said that you have both type of data from different phases. So, is it?
I mean,
The question is it requires any specific process with those data transfer?
In our case, we have the information. The starting point is the information of the infrastructure as it is, and on top of that, we put the information from the IoT, the inspection sensors, to keep the state of the infrastructure always updated. So I don't fully understand the question.
I think this question was about the technicalities. So if someone, let's say one company, use a digital twin platform for the construction phase, they have go through the process of the construction. The construction is ended, and someone else using different digital twin technologies will be responsible for the operational phase. How data between those two companies might be shared? What format of files might be exported from the construction phase to the operational phase?
So I think that from the construction phase, we should have the information in standards such as IFC, CPML, and so everything should be transparent because the digital twin should be created using standards.
Actually, I think that we all touched on that, and we've seen that more or less different projects follow similar formats, similar standards, and so on. So I think that there are many commonalities to that end, and I think that there is a lot of room for discussion between us. Right?
Yeah.
Yes, we have question there. Yeah. Yes.
No, go ahead. Okay, thanks.
Well, my question was about in COGITO, you mentioned that you provide for the initiation or the initialization of the process. You provide some guidelines for the end users to produce their BIMs or to enter their planning information in IFC. And maybe we should think about at the end of the construction process, when the delivery will be done, to provide some guidelines, also coming perhaps from the next phase, the exploitation phase, in order to deliver the as-is build infrastructure or building by itself, in order to ease this bridge between the two phases. I had also one question, because it's not planned in BIM2TWIN, for instance. We did not thought about that beforehand. And I was also questioning, because all of us, we are talking about graphs. Everything has been translated into graphs. Is it needed to go through IFC, or should we transmit, should we transfer a graph directly? And how?
Yeah, actually, we are not translating the whole IFC into graph. I mean, the geometry part from this data now is not considered on those graphs in IFC. We are taking into account all the metadata, how the elements are linked between them and so on, but not the geometric representation. It's quite complex as information to be processed and generate graphs. And at the end, we realized throughout the project lifetime that there is no need for such a transformation. More or less, applications that would like to utilize such information prefer to process the IFC as a file, because there are already available converters like IFC, IFC convert, that are able to transform this information and process the geometrical part. So at least in our project, we are not processing the whole IFC, but part of it that is required to establish linkage between the IFC elements, as individual is, for example, of specific elements, spaces, and so on, with other data generated by these applications. And with regards to the first part of recommendation, I fully agree with you that it makes sense to have also some guidelines with regards to what is the output of construction phase, what we want to deliver, but to this that exercise, it would make sense to also involve OMICRON, because they have the know-how with regards to the input data required for the operational phase.
That's why we had a chance to have a project that is dealing with the other phase.
Yeah. We also have a project, we also work on digital twin for buildings, and in particular we have another project which I will present it tomorrow, which is energy digital twin for buildings. So again, we take the information from the construction phase, and then we develop a digital twin for the operational maintenance of the building oriented towards energy issues. And yeah, I think that's a lot of there is one possibility. Okay.
Do we organize some workshops, right?
Yeah.
Together.
Yeah, and also we can stay because we have been not functional, but I'm very sorry because I should be already in your place.
Okay, maybe just a question from Edward. You want to start?
You were mentioning how to pass from design construction to operation. I think it's really important to consider things that are very like the ISO, which is mentioning how you are moving at least always focus on the okay, but how you are getting the build and how you are getting the asset information management. Obviously, this is more referring to be okay, when you are considering the digital, this is not all the, let's say, information related to migrants, related to IoT, related to simulation and other parameters. And obviously, how you could extract that data model along the whole life cycle, which would be a graph behavior reduce along the this is already very important.
Thank you. So I think this will be a good point for a conclusion, and as well the link for the next part of the workshop about the standardization. So how can all our projects influence, for example, on the data comparability or utility of data. So now we will have a 15-minute coffee break and then the standardization part. Thank you for this first one.